Hello everyone. For this tutorial video, I'd like to describe the square pyramid, which is the most simplest of the pyramids to analyze. Exactly like how the cube is the most simplest prism to analyze. A pyramid is geometrically defined as any shape whose sides are triangles that meet at the topmost point, formerly known as the apex. So in essence, it can be thought of as a 3D-ified version of a triangle. If we were to stop and break down the surface area of a square pyramid, it would become obvious that its bottom point is a square, and the sides that make it up are four triangles that are equal in area relative to each other. So the surface area would simply be the area of the square plus 4 times the area of one of the triangles. Or more simply put, the side length squared of the square base plus 4 times 1/2 the side length times the height of one of the triangles. However, even though the surface area was very easy to figure out, the volume will be much more difficult, owing to the fact that the cross-sectional area is no longer equal throughout the whole thing. However, we can see that because its bottom base is a square, it would be reasonable to assume that the volume can be estimated as a sum of infinitesimally thin rectangular prisms whose bases are all squares, but whose areas decrease the higher you go. We can see a mathematical formula that relates all these volumes is that with each layer you go up, the dimensions of an individual layer would be k, the length of that particular layer, divided by the total amount of layers n, and it would be squared owing to the base being a square, and then times the area of the original. Since we have figured out the area of one of the layers, we can see that the height of each prism must be the overall height divided by the number of layers, and so the volume of each slab will be that times the area we figured out. We next add all of these up and see that no matter exactly how long the calculation would get, A is always a common factor, and the height is as well. The number of layers is a common factor as well, but it's a little more tricky and not as straightforward. But we can see, since we are multiplying something divided by n times something divided by n squared, we would get something divided by n cubed because of how multiplying the denominators and fractions works. This is not the whole story for the total volume, however, because we remember for the cross-sectional area of each slice, one of the factors was an integer number, aka the layers number. And because the cross-sectional area was layer number divided by number of layers squared times area of original, all of these integers are squared before adding them up, which as an infinite series is a lot more difficult to prove than what we had originally. But if you were to experiment with different numbers, you would see the result always becomes 1/6 times the number of elements involved in the sum, times, in parentheses, the number of elements plus 1, times, in parentheses, 2 times the number of elements plus 1. Although generally, it cannot be proved through laws of algebra, the series can only be proven through number crunching and trial and error. But, with that result out of the way, we plug this in to our overall volume equation and get cross-sectional area times height divided by 6 times 1 plus 1 over n times 2 plus 1 over n. And because we assumed the layers were infinitesimally thin, this means that there would have to be an infinite amount of layers to make up the volume, and as n tends toward infinity, 1 over n, one of the factors in our formula, tends toward 0, because the greater the number you divide, the smaller the result. So our final answer for the overall volume is cross-sectional area of base times height divided by 6 times 1 times 2 equals cross-sectional area times height times 2 divided by 6 equals cross-sectional area times height divided by 3, as 2 divided by 6 simplifies to 1 divided by 3. Although we could assume, based on visual estimation, that a pyramid is 1/3 the volume of a prism, we must remember that in geometry, making assumptions based on what you see is not how you prove things, but rather by strict mathematical definitions. Now that I've given a comprehensive proof of the surface area and volume of a square pyramid, we can investigate the surface area and volume of a rectangular pyramid. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.